Alright chemists, so today we're going to look at cellulose as a polymer, and in particular cellulose as a biopolymer. Now you've actually got a few videos we're combining together, so this one will be quite short. This is all of what we'll be covering in these three videos, not just today's, or not just this one. Alright, so biopolymers. These are basically polymers that are produced by anything that's alive, and you are essentially made up of mostly biopolymers. Cellulose, starch, DNA, proteins, these are examples of biopolymers that we should be relatively used to by now. Glucose is the monomer of cellulose and starch. Now, we'll get into what glucose is in a minute. And yeah, so cellulose and starch, cellulose is the one we're going to look at today. And given that they're biopolymers, this means they're made with an enzyme inside a living organism. And these guys are formed through a condensation polymerization. This means that when they are added together, it ejects a water molecule. And this is going to become a common thing throughout the rest of our course. So this is a glucose here, and you see that it is a single unit of sugar. And this is alpha glucose, and this is beta glucose, and you can see that in an alpha glucose, the hydroxyl groups here and here are the same side, and in a beta glucose they are the opposite side. And when you turn it into a straight chain, so at the moment it's here as a ring molecule, when we straighten it out it makes no difference, both are the same. And here are the three biopolymers that are the most common throughout our body. We have cellulose, which has the alternating groups, that's this group here, so alternating groups there, there, and there, and there. And here we have it all on the one side in starch. So cellulose, it alternates, and in starch it is on the same side. So this is the repeat unit of cellulose. Now, I know we said it's glucose, which means it is just the one side over here, but because cellulose in particular has the alternating structure, it is the two of them which is the repeat unit. Okay, so this is our monomer, but this is our repeat unit right here. And this is what it looks like as when it's a long chain. Now, you'll see that they're on the opposite. Well, we'll get more into that in class. But that's what the structure actually looks like. So we always see it drawn as these nice straight, chains like this. But in reality, it's these chair structures that look like this. And you can see there is all these hydrogen bonding happening. So there's hydrogen bonding, there's hydrogen bonding, there's hydrogen bonding. And that's what allows cellulose to be actually quite dense as a molecule. So it's quite dense and tightly packed. And you can see here that cellulose, because it has these alternating side chains, it allows it to get nice and tightly packed, whereas starch never packs that tightly, and the hydrogen bonding won't be as strong or severe. Alright, and enjoy the rest.